Good afternoon. My name is Collins. Welcome to my channel. I'll be taking you through the journey of mathematics. Today we'll be starting with logarithm. So we are going to learn what logarithm is, starting from the definition of what logarithm. Let's quickly see the definition of logarithm. So we said that logarithm of a number to any base is that power to which the base can be raised to get the number. Thank you. So we said that logarithm of a number to any base is the power to which we are going to raise the base to get that very number. Mathematically, look at what we are saying. Assuming I have logarithm of what? Base A of B. If I have something like this, the first thing I want to do is to make this to be an equation. How do I make a mathematical expression to become an equation? I will use a very simple assignment. I will say, let log base A of B be equals to what? X. So what do you mean that x is now the answer to this very logarithm? Now, judging from the definition of logarithm, where we say that logarithm of a number or logarithm to any base is the power to which we are going to raise that base. Now, look at this logarithm. What's the base of the logarithm? The base is actually A. So, what power can I raise A to get this very number B? So we are saying that the base of the logarithm will become the base of the indices that we want to form, while the other side of the equality sign becomes the power. So we say that this raised to power s is equal to what? B. So the A is the base of this logarithm. So this is what we call the log form. Let's say the log form of expressing numbers, and this is what we call the index form. So persons can call it the power form, or even the exponential form of what? Expressing number. So what we are trying to say here is that there is a relationship between logarithm and indices. For every logarithm equation that you have, there is what? A corresponding index form for it. Assuming I have a logarithm form. Okay, let's quickly see log form and index form. Assuming I have log base 10 of 1000. What we are saying is, what can we raise the base of this logarithm, which is what? 10, to get this very number 1000. So we can say that the base of the logarithm will be the base of the indices, while the power of the index form is going to be the answer to the logarithm. So we are going to say that this is going to be raised to the power of 3 will give us what? 1000. So this is the corresponding form of what? This logarithm form. Assuming I have something like, again, log base 2 of 8, what will be the corresponding form? The base of the logarithm will also be the base of the indices. While the power to which we can raise to obtain this very number 8 is also what? 3, and this will also give us what? 8. Okay, quickly, this the major relationship between a logarithm form and an index form. Meaning that if you give me a question, a logarithm, I can move to its index form, and it's easier to solve a logarithm, or it's easier to solve an equation in index form than logarithm. Let's quickly see example. Assuming I'm giving a question like this. Let's say this example 1. So log base 4 of 0.0625. How do I solve something like this? Now, join by step. So the first thing I will do is to make this logarithm expression to be an equation by simply saying, let log base 4 of 0.0625 be equals to x. Let log base 4 of 0.0625 be equals to what? X. Now this is the log form of this equation. Is it an equation? Yes, because of the equality sign. We are saying that whatever that is on the left hand side is exactly the same with what is on the right hand side. Now if this is the log form, we are saying that we have a corresponding index form of this equation. What will be the corresponding index form? We are saying that the base of the logarithm will also going to be the base of the index form. What's the base here? 4. And we are saying that the power of the logarithm or the power of the index is going to be the answer or the result of the logarithm. So this part, we can say that this is raised to the power of what? X, and it will be equal to this very number here, which is 0.0625. So that will not have an index form. We now have an index form. So how do we proceed to solve this? We have actually moved from logarithm to what? The index form. So how do I want to solve this? So the first thing says my right hand side is a decimal number. The best thing I want to do is what? To express this as a fraction. So we can say that 4 raised to the power s will also be, when we convert this to fraction, we are saying how do we convert to fraction? This is 0.0625. If I want to convert to fraction, I will come right under the decimal point. I will use 1 to actually remove the decimal point. Now the number of digits here, the number of digits immediately after the decimal point determines the number of zeros that I will put at the denominator. Since we have 4 digits here, so I'm going to replace them with what? 4 digits. So that this number becomes 625 over 10,000. Now when we further reduce this, to its lowest step, we can now say that 4 raised to the power s is equals to 625 divided 625 will give us 1. When 625 divided 10,000, what are we going to have? We are going to have what? 16. So this is actually 1 over 16. Now since 16 can also be expressed in terms of 4, that means we are closer to our answer. So the next thing I want to use, judging from the laws of indices, immediately I see 1 over 16, what comes to my mind? The laws of what? Negative indices. And what does the law of negative indices imply? It says that if I have something like 4 raised to the power s 1 over 16, I can also write this as something as 16 raised to the power of what? 1 minus 1. 16 raised to the power minus 1. Okay. So 4 raised to the power s is equal to what? 16 raised to the power minus 1. Now we are already in the index form. This is actually 4 raised to the power x, which is now equals to 16 raised to the power of what? Minus 1. I'm going to ask myself a simple question. This is what an equation. Equation simply means that whatever that is on the left hand side is exactly the same with what you are seeing on the right hand side. Now on my left hand side, I'm having 4 raised to the power x. On my right hand side, I'm also having 16 raised to the power minus 1. I will ask myself a simple question. Can I express both the base of the left hand side and the base of the right hand side to have a common base? If yes, that means we are closer to our solution. Yes, and we can actually express 16 to have the same base as what? 4. So we can now say that this is 4 raised to the power x is equal to what? What is 16? Is certain as 4 raised to the power what? 2. I can use bracket to say all raised to the power what? Minus 1. Have I changed anything? No. What is 4 raised to the power 2 is the same thing as 4 times 4, which is what? Still 16. Meaning that I have not changed the value of what? 16. I will proceed to what? Remove the bracket here. So I can now say that 4 raised to the power x is equals to what? 4 raised to the power minus 2. Now look at this. This is what? An equation, and their base are what they say. If this is going to be equal, we are saying that x must be equal to what? Minus 2. And I can state the reason by the side. The same base. The same base. Therefore, we can now quickly conclude our solving that log base 4 of 0.0625 is equal to what? Minus 2. Thank you and God bless you. Thank you for joining us. I believe that you are going to follow up for the next videos that will be coming up. In our next videos, we are going to see laws of what? Logarithm, how to apply those laws of logarithm, and how to even derive those laws of what? Logarithm. Thank you and God bless.